Algebra 1, Lesson 101 and 102. We're going to be starting with solving multi-step absolute value inequalities. So we've seen these inequalities before and absolute values, we're just making them slightly more complicated. So remember that when we have these absolute value inequalities, if we see a less than or equal to symbol, that's really our and situation, meaning we have a compound inequality that is going to converge on itself. It's an intersection. Whereas a greater than symbol, or greater than or equal to, is an or situation, meaning if we were to graph it, we have lines going away from each other. This is actually a union if you're thinking about number sets. So 3 steps here to do our multi-step absolute value inequalities. Number 1, you need to isolate the absolute value expression, so get those bars by itself. Can't do anything with what's inside of it yet, but just get the absolute value alone. Number 2, use the absolute value expression and then switch the symbol and take the opposite of the number. And I'll show you what that looks like in just a second if you've forgotten. And then number 3, solve both sides. So let's look at 1. If I have 2 times the absolute value of x plus 3 is less than or 11, we can already know because this is a less than symbol, it's probably going to end up an and situation, so that when we graph it, we have 2 lines going towards each other. Just like any other equation, I have to get something alone. In this case, it's the absolute value. So I'm going to subtract 3 from each side and get 2 times the absolute value of x is less than 8. And I'm going to divide by 2, so we get absolute value of x is less than 4. So I have the absolute value isolated now, and I need to split it up into 2 different inequalities to say x, so whatever's inside of the absolute value, is less than 4. And then I have another one. I have x is greater than, we switch the sign, and we use the opposite of the number, negative 4. Which now, I already have the x by itself in this case. I can write it as a compound inequality by switching the second equation around and have negative 4 is less than x. And then I'm going to combine it with the second one here. X is less than 4. Which means if I were to graph this, I have my negative 4 and 4. I have open dots on both of them connected in between. Now on the next one, very similar, we subtract 1 and get 4 times the absolute value of x is less than 20. Divide by 4 and get absolute value of x is less than 5, which means x is less than 5 and x is greater than negative 5, which means I get negative 5 is less than x, which is less than 5. Very similar to here, okay, but instead of negative 4 and 4, we have negative 5 and 5. Let's just do a few more examples of this. Pretty straightforward though. Okay, negative 2 times the absolute value of x plus 6 is greater than 1. I'm going to subtract 6 on each side and get negative 2 times the absolute value of x is greater than or equal to negative 5. And then I'm going to divide by negative 2. Now remember that if I divide or multiply by a negative number, I'm going to switch the sign to be a less than or equal to sign. So I have the absolute value of x is less than or equal to 5 over 2, or you could write it as 2.5, which means I can separate it into my 2 different inequalities. X is less than or equal to 5 over 2, and x is greater than or equal to negative 5 over 2. Ends up being just like what we saw on the other page. We have negative 5 over 2 is less than or equal to x, which is less than or equal to 5 over 2. Only difference here is that even though they go together, they are closed dots because I have less than or equal to. You can try the next one on this page for yourself, very similar. All right, now sometimes we come up against word problems here for these inequalities, and the hardest part is just writing the inequality. So NCAA rules require that the circumference C of a basketball used in a game may vary no more than 0.25 inches from the 29.75 inches. Write and solve an absolute value inequality that models an acceptable circumference. What is the smallest acceptable circumference? So remember that when we set up these absolute value inequalities, how I set them up is saying I have a certain variable, in this case c, which is what I actually have. And I want to know what that basketball, if I were to just pick up a random basketball, I don't exactly know the circumference until I actually measure it. I need to make sure that the difference between that circumference and what is acceptable, this 29.75, isn't any bigger than 0.25, meaning I have, the C represents what I actually have, the 29.75 represents what I should have, and I want to make sure that the difference is no larger than 0.25, meaning that I need this to be less than or equal to 0.25. Whenever you do these absolute value inequalities or equations, make sure that if you're talking about that plus or minus amount, that error amount, it's always outside of the absolute value. So that we can solve these to say, I'm going to take what's inside, since it's already isolated, say C minus 29.75 is less than or equal to 0.25, and C minus 29.75 is greater than or equal to negative 0.25. Okay, and then we can solve this by adding 29.75 on each side to get C needs to be less than 30 inches, but it also needs to be greater than or equal to 29.5 inches, meaning it just has this small window of acceptability. It's from 29.5 to 30, okay? It needs to be between those two amounts, or else it won't be acceptable as a regular NCAA basketball. You can try some of these on your own. Just remember, isolate the variable, okay? Do those opposite operations, so plus 4 times 5 plus 4 times 2, okay? I'll just show you one of these. So let's say I do the top one, and I add 4 on each side to get absolute value of x over 5 is greater than 2, times 5 gives me absolute value of x is greater than 10, which means x is greater than 10 or x is less than negative 10. Now I know that it's an or because I have a greater than symbol here. Because when I graph these, and no, I can't combine them anymore into one long inequality, I can say my negative 10 and 10 here, open dot going to the right for the x is greater than 10, open dot going to the left for x is less than negative 10. All right? Greater than symbols are an or situation. Okay? Now, these ones here, if there's more than just x inside the absolute value, still have to get the absolute value isolated and separate them. We can't get rid of that plus 5 yet. So I add 1 on each side and get absolute value of x plus 5 is greater than 8. So now I split it to say whatever's in the absolute value, so x plus 5 is greater than 8, or x plus 5 is less than negative 8. And now I can solve them. I can subtract 5 from each side to get x is greater than 3, or x is less than negative 13. And these are going to be in separate directions when you graph them. Open dots, and they will be going in separate directions. You can try the next one on your page for yourself. It can get slightly more complicated, but it's really not all that much different. I'll just do this top one. So we're going to subtract 12 and get absolute value of x over 3 minus 2 is less than or equal to 7. And now I separate it. X over 3 minus 2 is less than or equal to 7. X over 3 minus 2 is greater than or equal to negative 7. This is an and situation since I have a less than symbol. And I can add 2 on each side and get x over 3 is less than or equal to 9. And then I'm going to multiply by 3 to get x is less than or equal to 27. Over here, add 2 times 3. We get x is greater than or equal to negative 15. If I did that quickly in my head, we get plus 2 minus, yep, negative 15. Which means that we can combine this inequality since it's an and have negative 15 is less than or equal to x, which is less than or equal to 27. Okay? And I do have a separate example down on the second one here, so you can try that for yourself. And I just have one more word problem here that you can try. The acceptable radius for a tire must not vary more than 1.4 centimeters from 33 centimeters. So when we write this absolute value inequality, we should say, I have some type of radius amount. It shouldn't have a difference from 33 of more than 1.4. Okay, so what I should have, that difference needs to be less than or equal to 1.4. And you can split that up and solve. Okay, there's a couple more examples here for you if you need more tries. All right, now let's do lesson 102 as well. So lesson 102 is about solving quadratic equations using square roots. This comes up in the book previous to ours, and it's really a very simple way to solve these quadratics. We're going to use this in a later lesson here when we're combining it with some factoring. So quadratic equations sometimes have an exponent with a variable, actually always, and that exponent is 2. That's how we know it's a quadratic. So how do we get rid of exponents? Well, if it's a 2, if it's an exponent of 2, we would square root. Exponent of 3 would cube root. We use roots in order to get rid of exponents. So remember that with quadratic equations, we can have 0, 1, or 2 answers. So visually, we know what this looks like already, but in our quadratics, let's think about these. And we would say, if I have x squared equals a, if that a is greater than 0, let's say it's 25, I'm going to have 2 answers. Well, that's because with our example, x squared equals 25, we could say that 5 would work for x, but so would negative 5. Okay? Thinking about our actual quadratic, it's because it crosses that x-axis twice. Now, what if that a equals 0? Well, if a equals 0, then I have x squared equals 0, and only 0 times 0 would equal 0. So I just have 0 as my answer. And if it's less than 0, we will have no answers. Well, that's because if I have x squared is equal to negative 9, and I try to square root each side, this is not possible in real numbers. We can't take the square root of a negative 9. So we say we have no real solution. So here are a few examples. X squared equals 25. Well, we would say that's 5 and negative 5. X squared equals 121. We take the square root of each side, and we say that that's 11 and negative 11. X squared equals 289. That's 17 and negative 17. X squared equals 576. Take the square root, and we get 24 and negative 24. And then let's try these ones. X squared equals negative 16. Well, if it's less than 0 and we try to square root each side, that's not possible, so we say no solution. And same with this one, there's no solution. X squared equals 0, x is equal to 0. And x squared equals 256, that means x is plus or minus 16. Okay? Now, what if we don't just have x squared on that side? We have something like ax squared plus c equals 0. Or even something like this. Well, we're going to have to get it so that the x squared is by itself. So we're going to, in the first case, subtract 3 and get x squared is equal to 49. So that we can square root each side and say x is equal to plus or minus 7. Same with the one over here. We can add 15 to each side and get 64 is equal to x squared, meaning that we get x is plus or minus 8. All right, so get your x squared alone so that you can take the square root of it and see your different solutions, whether that's 2, 1, or 0. Okay, but sometimes it won't be perfect square, so we need to either simplify the radical or find an approximation. So for example, x squared equals 40. I could take the square root of each side and say x is equal to plus or minus root 40. But that root 40 can simplify, remember, break it up into, you could say 4 and 10, 2 and 2, 2 and 5, so that we could say this is plus or minus the square root of 2 times 2 times 2 times 5. Circle and pop some 2's and get plus or minus 2 root 10. Now, if we want to approximate this, yes, we can do it by hand, or sometimes we're allowed to use a calculator, and we would just say something like square root of 40 is approximately 6.32, which makes sense. It's between the perfect square of 36 and the perfect square of 49, so it has to be between 6 and 7. All right? The next one, we would take the square root, and we actually can't simplify the square root of 62, but we can approximate it to say the square root of 62 is just 7.87. All right? Excuse me. Let's look at a few more. So what if we told you this? Malik covered a cube with exactly 864 square inches of self-stick vinyl. What's the side length of the cube? Well, how do we find surface area for a cube? Well, if I have a cube like this, we are saying that all of those surface areas are the same. We have 6 of the same surface areas. So if we say that the side length is S by S by S, we would say S squared is the face of one of those. And I have 6 of them, which means the surface area equals 864. So we can divide by 6, get S squared is equal to, I believe, 144, which means that S is equal to plus or minus 12. Now, if we're talking about something real here, like a cube, we would just pick the positive one. Okay? So you can try this part on your own. What would happen if he didn't want to cover the bottom of the cube? What would be the side length of the largest cube he could cover now? So if he still has that 864 inches of self-stick, but we don't have 6 of them, we only have 5 of these faces, well, what would be the largest that you could do? So you can think about that, all right, and solve. Okay, similar idea here. You can try that on your own. And here are some others. I'll just pick a few here. So maybe we take 3x squared minus 75 and add 75 to each side to get 3x squared is equal to 75. Divide by 3 and get x squared is equal to 25. So x must be 5 or negative 5. Okay, or maybe you try this next one. Add 60 to each side and say 5x squared is equal to 60. Divide by 5, and well, that gives me 12, so x squared is equal to 12. And when I simplify this, I just have to say x is equal to plus or minus square root of 12, which is actually 2 root 3. Or you can approximate it with a decimal, okay, depending on what is asked. All right, and a golf ball is dropped from a height of 1,600 feet. Use the equation to find how many seconds it takes for the ball to hit the ground, meaning that I want to be at 0 feet, which is why we have it equal to 0. So I just need to find t time, which when I do this, I'm going to add 1,600 to each side to get 16t squared equals 1,600. Divide by 16 to get t squared is equal to 100. So t must be 10 or negative 10, which if we're talking about time, I would probably pick the 10 seconds, the positive 10. Theoretically, if we were to go back in time, it would also hit the ground at negative 10 seconds. All right, you can try these for yourself here. Okay, and this one, last page. Lots of different examples that you can try for yourself, work out, and simplify those radicals if there's nothing more to do. All right, well, I hope this helps for your homework and for studying.